Yes. So let's discuss chi-square test. It is an important test. I hope everyone remembers our levels of measurement. To understand chi-square test, you have to understand the levels of measurement: nominal, ordinal, interval, ratio. The four levels of measurement. I hope you remember that. In that, I hope you understand nominal. I remember I told you not proper numbers. You're just assigning random numbers: Hindu, Muslim, Christian, 1, 2, 3. Even if you change that ordering, it is okay. The other next level was first, second, third ranking numbers. Suppose income categories: low income, middle income, high income. There you cannot interchange. There is some degree of uh, uh, order between them. But then they also are not proper numbers using which you can do all kinds of mathematical operations. We have just given them numbering, but it is a bit more better than nominal. That is why together nominal and ordinal numbering categories, levels of measurement means numbering categories. You can call them as categorical data, which means they are not actually pure numbers. We just use them to categorize or classify groups. That is the only use for that. The other two were ordinal and interval and ratio scales. Interval scale, remember I gave you the example of temperature and all. Between 1 and 2, 2 and 3, and 3 and 4, the numbers are meaningful. If you take first, second, and third ordinal numbers, first, second, there is a clear distinction between that, but what is there between 1.1, 1.2, 1.3 has no meaning in ordinal data. But if you come to ratio data, that midpoints, decimal points in between are meaningful. 1.1, 1.2, 1.3 is meaningful. It is the only thing is that is also not the purest kind of numbers where zero is meaningful. No zero is meaningful. Take for example temperature. 0 degrees Celsius does not mean much. It is just an arbitrary number. Not just that, you cannot say that if say suppose uh, one or suppose 10 degrees Celsius is the is twice that of 5 degrees Celsius. That is not mathematically meaningful. Ratio is normal pure numbers. 2 meter is the exact twice that of 1 meter, and 0 meter is also absence of that thing is real. So height, weight, such numbers are proper pure numbers, ratio numbers. Now, the first two, nominal and ordinal, together we call them categorical data because they are not pure numbers. They are just used to categorize. The other two, ordinal and interval, we call them pure numbers or continuous numbers. So categorical and continuous. To do correlation, regression and all, both your variables should be continuous, ordinal or interval or ratio numbers. But what if your data is categorical data, nominal or ordinal? Now you cannot do regression, sorry, correlation, right? So to find out the relationship between two variables which are categorical data, which you have not taken as continuous data, for that you actually use chi-square test. So chi-square test is something similar to correlation, but not as useful as correlation. Correlation gives you the strength of the relationship between two variables. Correlation gives you the direction. This gives you nothing like that. It only tells you that there is an association between two variables. It only gives you association, no strength, no direction, what was the other word? I'm not getting it. No strength, no direction, nothing. So in that sense, correlate chi-square is a bit more of an inferior test used to find out the association between categorical variables, categorical data. So now here again, same thing. You observe something. Is it a coincidence or is it a real association? What does that mean? You observed something in your small group. Is that there in your population? Larger group also. So note it down here. Chi-square test is a statistical test used to determine whether there is a significant association between Categorical variables. I hope you understand what categorical variables are now. So see, categorical variables are frequencies. They're just counts. They are not continuous data. I hope you now understand. Continuous data means 1.1, 1.2, 1.3. All the midpoints are also meaningful. For just nominal and ordinal variables, you just are counting them. You just are ranking them. That midpoints are not meaningful. That is what I meant there. Now, is there a relationship between two categories is what we are studying here. So the equation is this. This is a Greek or Latin letter called chi. It looks like X. It is called chi. This chi-square test is what? O means your observed frequency. E is your expected frequency. You so you subtract that and you square it to eliminate the negative values. Here also what I would suggest is you don't give too much importance to the equation and all. Just understand what the test is. If someone asks you what a chi-square test is, if you can explain whatever I explained now, you will get proper marks for it. And you again divide it by the expected frequency. So again, hypothesis testing, I'm not getting into details. Uh, you again look for the p-value. Depending on that, you reject or accept the null hypothesis. Now here also same thing. You see gender and preference. Preference as in what? Preference for coffee, tea, yes or no answer you would get. Gender, you will get male, female answer. So both categorical variables, right? You cannot do correlation. In that case, you can only do what? You can only do chi-square test. So chi-square test analyzes the relationship between categorical variables using frequency data, not continuous data. Okay. So I hope that is clear. You have a kind of a rudimentary idea now about chi-square test, I hope. So I hope you now have a kind of a 360-degree idea about a lot of these tests. Now, please go do your extra bit of reading.